Thanks. All right. So I'm Simon, and I'm here to go over how I've come to enjoy building Swift apps with loose coupling, pure dependency injection, and the composition route. And hopefully, I can inspire you to think about how you build your Swift apps. So I think it goes without saying that we all strive to build to make our code loosely coupled, so we can make modifications in parts of our system without introducing unintended side effects in other parts of the system. And we know that one way to achieve loose coupling is through abstractions. So for example, the dependency inversion principle states that high-level modules should not depend on low-level modules. Instead, they should both depend on an abstraction, like we see here. And just a reminder, in Swift, an abstraction can be a protocol. So when we start to use abstraction, or when we use abstractions, we will at some point need to provide our consumers, that is the consumers of our dependencies, with implementations that conform to these abstractions. And we use dependency injection to provide a consumer with an implementation. And when doing so, it becomes apparent that dependency injection is a technique that enables loose coupling in our code bases. And throughout this talk, we'll be focusing on initializer injection. And that's because initializer injection is ideal for dependency injection because it's fail-safe by design. And that's because the compiler enforces the relationship between a consumer and its dependency. And that's the case because the initializer specifies that a consumer of a dependency cannot exist without an instance of that dependency, at least when we're working with non-optional dependencies, which I think we should. So in this talk, we'll be injecting dependencies manually using initializer injection. And now you might be like, whoa, Simon, what are you talking about here? Injecting dependencies manually. Haven't you heard about this new framework or this fancy design pattern that makes everything way easier? Why would you want to inject dependencies using initializer injection and even do so by hand? And yes, I have heard about this framework and these new design patterns, but they're just not for me. And that's because my experience with these are that they mostly introduce anti-patterns in our code base that either means that the dependencies of a consumer is hidden, so we cannot know the dependencies without looking at the internals of our components, or that these introduce a tight coupling either to a dependency injection container, which is a type in which we have all our dependencies registered, or they introduce tight coupling to the framework itself. So we now have that framework spread across our entire code base. And using pure dependency injection with initializer injection, we can prevent that. And I'd like to show you how that works. And I'd like to present this app called Coffee Shops. So I like to work from coffee shops, so I made this app so I can keep track of the coffee shops that I've visited and rate them and so on. And we'll use it as an example going throughout this presentation. So I'll just give you a highlight of the app. The example app has 4 features. The first one is the onboarding flow, where users can create an account and they can sign in. Once they're signed in, they're presented with a map that shows all the nearby coffee shops. And they can select the coffee shop to view its details and rate it 1 to 5 stars, and even add a note to remember what made this coffee shop special. And then finally, they can visit their profile, where they can see the membership status, the coffee shops they previously visited, and they can log out. Now let's consider what happens when we start adopting initializer injection in our app. And we'll do that in the context of this profile view. So a profile view like this might have a dependency on an authenticator that conforms to the authenticating protocol. And you can imagine an authenticator like this having a function called logout that will log out the user from our app. And when doing so, it also clears the credentials that we have stored in our credential store. So it has a dependency on credential store. Then we have our Swift UI view called profile view. It depends on the authenticator. And our profile view might also depend on a repository that contains the coffee shops that we previously visited. Now it's starting to become clear that we're working with a graph here, an object graph, where profile view depends on something that conforms to authenticating, which in turn might depend on something that conforms to credential storing. And also our profile view has a dependency on the repository. But this is only part of our app. Our app is much bigger, and it's even bigger than this. Or it's only part of our object graph. It's much bigger. But with the introduction of Swift packages, it has become popular to move logic into separate Swift packages. And because we have a loosely coupled code base that uses dependency injection, it becomes quite straightforward to move our components into separate packages. And I like to move components into feature packages. So each feature in my app lives in isolation in a Swift package. And these packages are loosely coupled. Now they might have dependencies on some library packages that contain some shared logic. So feature packages can depend on library packages, but feature packages cannot depend on each other. So let's go ahead and do that. And we'll take everything related to the onboarding of the user, throw it into the onboarding feature package. Everything related to the profile, throw it into the profile feature package. Everything related to the map, throw it into the map feature package. And I think you see where this is going. We'll take everything related to the coffee shop details and throw it into the details feature package. Now, everything that remains is the logic we have concerning authentication, and we'll create a library Swift package called authentication that our other feature packages can depend on. Now, just a note, we haven't gotten rid of our object graph. It's just distributed across multiple Swift packages now. It still exists in our code base. So the question we need to ask ourselves is, how do we compose this object graph? That is, how do we create the consumers of dependencies and the instances of these dependencies? So this book, Dependency Injection Principles, Practices, and Patterns by Stephen van Dersen and Mark Seemann answers this question among many others, but it answers this question by introducing the composition root. And a composition root is it's defined as a single logical location in an application where modules are composed together. Now, in our case, the modules, that's our Swift packages, or rather, it's the targets within those Swift packages. And this single logical location is something we need to identify. We need to identify a point in our application where the composition of our object graph can be logically organized. And we'll go ahead and do that together in just a second. But we are told that this location should be as close as possible to the application's entry point. And that's quite natural, because when we use initializer injection, we will defer the initialization of our dependencies for as long as possible. And at some point, we cannot defer it any longer, and therefore we'll find ourselves, and at that point, we'll find ourselves close to the application's entry point when we just defer it for as long as possible. And note here, the application's entry point is the first code that's executed when the system hands off control to our app. That means that the composition of our object graph is one of the very first things that's done when the system hands off control to our app. Now recall a second ago, we took all our UI and our business logic and we moved it into these separate Swift packages. And with our components being loosely coupled, using dependency injection and living in separate modules, it becomes the responsibility of the composition root to tie these modules together. In other words, our composition root creates both the consumers and the dependencies of those consumers in these loosely coupled Swift packages, to tie them together, to tie both the components in these packages together, but also the packages itself, right? Now, and since all our UI and business logic lives in the Swift packages, there's no meaningful logic left in our app target. And as such, we can regard the composition root, or we can regard the app target to be our composition root layer. Now, it's key to note here that the composition root is it's a layer. It's not a single type. That's a mistake I made when I started adopting the composition root. I thought that's just a struct or a class within my code base, but that's not the case. It's a layer that spans multiple types and can live across multiple Swift source files. And we'll see how that can work in a second. One thing we should note, though, is that this composition root layer is made up of composers. And a composer is really just a function or a property that creates a part of our object graph. That is, a composer creates the consumers and the dependencies of those consumers, one or more consumers and one or more dependencies. So let's head into Xcode and see how all of this works. And we'll start by opening our coffee shop's example project. And the first thing you'll notice is that we have a bunch of Swift packages. They're the packages that we created just a second ago. So there are our feature packages and our authentication package, and then a few more library packages that were previously left out for brevity. Then we'll head into our app target, the coffee shop's app, and you'll see that it contains just a single Swift source file. Now remember, there could be multiple source files here, but for the purpose of this example app, having our entire composition root live in a single source file is just fine. The next thing you might notice is that we have a bunch of imports here. And usually that's a code smell, but in this case it's actually just fine, because the entire purpose of our composition root layer is to depend on all of our modules and tie the components within those modules together to form our object graph. But we should note that the composition root is the only place in our application that's allowed to depend on all the modules. Anything else would be an anti-pattern. So let's scroll down to meet our first composer, and we'll turn our attention to the coffee shop's abstract that conforms to the app protocol. And here we'll find two composers. Their properties, and they're the credential store property and the DB property. The credential store creates a keychain credential store that contains our users' credentials, and the DB property holds a reference to an instance of Swift Data DB that sets up our Swift data stack. And these are composers that creates a single object in our object graph. And we store references to these in the struct so we can inject them into multiple components in our object graph later on to share state between these composers. Share state between these objects. Then we'll turn our attention to the body composer, which is just a property. And the body composer creates the one and only scene in our application, and that scene contains an onboarding view. And that onboarding view lives in the onboarding feature package. And in order to create that onboarding view, we need to inject the dependencies, and it has a dependency on an authenticator. Now, authenticator is in itself a composer, and we'll see how that's implemented in just a second. But what we are seeing here is actually a key concept in our composition root, namely that a composer is allowed to call other composers to create an even bigger part of our object graph. Then we pass a closure, specifically a view builder, in which we create the view to be shown when the user is authenticated, and that contains a tab view, which holds our map view and our profile view that also lives in separate Swift packages. So here's an example. This is an example of how we can tie loosely coupled Swift packages together. So we have the onboarding view living in the onboarding feature, the map view living in the map feature, and the profile view living in the profile feature package. And we'll see how these composers are implemented in a second. But what we see here is actually that our composition root ties all of these Swift packages together. They don't know anything about each other. So let's scroll down and meet 3 more composers. We'll see the profile view composer, the authenticator composer, and the visited coffee shop's repository composer, and we'll go through them now. So first we have the profile view composer that creates and returns an instance of profile view. Note, this is just a getter-only property that creates and returns this profile view. And in order to create the profile view, we also need to create its dependencies. Once again, we have a dependency on the authenticator, and here we see the implementation of the authenticator composer. It creates and returns an instance of authenticator, and in order to do that, we inject the credential store that we created earlier in our app and kept the reference to. Then finally, our profile view also has a dependency on a repository that holds the coffee shops we visited. So we call our visited coffee shop repository composer to return that. Now, I enjoy having tiny composers in my code base, especially for composers that are called by multiple other composers. So here we see 2 tiny composers. And having these tiny composers lets me easily identify a point in my object graph that contains some logic that I'm interested in swapping out. For example, here, I might be interested in returning a mock authenticator to simulate that the user is logged in with a specific type of user, maybe. So I just return a mock authenticator in my authenticator composer, and now I've changed the objects in my entire object graph, and I've changed the logic in my entire app. Let's scroll down and meet our last composer, and that's the map view composer. And you'll see that it's very similar to the ones we just saw. We create an instance of map view, provide its dependencies, and then finally, we once again have a trading closure that's a view builder that creates and returns the view to be presented when the user selects a marker on our map. So that's the details view that's presented when selecting that marker. And that's another example of, it's basically the same technique we're using here to tie multiple Swift packages together. We could use other techniques, but using view builders is fine for our case. So we've just learned that a composition root lives in our app target to create the object graph using composers. And we can use this knowledge to easily create dev apps. So I think this concept was originally presented by Airbnb, and I've recently started adopting dev apps in my Xcode projects. Dev apps are just separate apps that lives, or separate app targets that lives in our Xcode project to create apps that launch directly into a specific feature, and that feature might live in a separate Swift package. Our project actually have four dev apps. There's the onboarding dev app, the map dev app, and the details and the profile dev apps. And these apps rely on stop data and mock behavior, so they're consistent every time we run them. And they become straightforward to create when adopting the composition root, because each of these dev apps are just an app target that contains a composition root. That's very similar to the one we just saw for our main app, except these composition roots are obviously way smaller because they create object graphs that only span a single feature. If you want to learn more about how I created these dev apps, but trust me, it's just like what you just saw, you can go to github.com/shapehq/coffeeshopsexample to download the entire code base for this example app. Now you might be thinking, what about our unit tests and what about our Swift UI previews? At least these are questions that I often get when discussing the composition root with developers. And fortunately, the answer is quite straightforward. Because our unit tests and Swift previews, they don't care about the introduction of this composition root. Because we're using initializer injection, we can still inject mock behavior into our unit tests and stop data into our Swift UI previews, just like we've always done. In fact, we can consider each of the unit tests and each of the Swift UI previews to be their own tiny composition root. And that's another example of, it's basically the same technique we're using here to tie multiple Swift packages together. We could use other techniques, but using view builders is fine for our case. So And of course, this example app has unit tests and Swift UI previews, so you can also see those in the example app, or in the code base for the example app. Of course, this is all fine and dandy for a simple example app, but this also scales to much bigger apps, and I've used it in much bigger apps. Even if you're not using the composition route right now or initializer injection, you still have an object graph in your app, and that's whether your code base is loosely coupled or not. The composition route just makes the existence of this object graph obvious, and that has some benefits. So for example, if someone were to modify our implementation of Authenticator to add another dependency, for example, something that conforms to the logging protocol, then that modification of the graph will be surfaced as a compile time error in our composition route layer, reminding us that we need to tweak our Authenticator composer to inject an instance of an implementation that conforms to the logging protocol. And if you want to learn more about dependency injection and the composition route, then I urge you to read this book, Dependency Injection Principles, Practices, and Patterns. That's where I've learned most of the things we've discussed now, and then I've adapted them to a Swift code base. And if you're interested in learning more about how you can move your code into Swift packages or create dev apps, then I recommend reading this article by Airbnb called Designing for Productivity in a Large-Scale iOS Application. And with that, I encourage you to think about how you can use Pure Dependency Injection and maybe the composition route to build loosely coupled Swift apps. Thank you.